Hi everyone, welcome to this lesson where today we're talking about the geometric mean. So the geometric mean is the positive square root of the products of the extremes. And that sounds kind of crazy, like what does this even mean? But get it? Sorry. So the geometric mean is the positive square root of the product of the extremes. And when you're given a right triangle, there's so many crazy things that end up happening. When you create a right triangle, and you can see I have a big right triangle here, and I have my right angle at the top. And you create an altitude from one of those vertices. And in fact, this vertex is from that right angle. When you create an altitude from that right angle, what you're actually creating are now three separate right triangles, but they all have angles in common, and they have sides of the triangles that have two different purposes. So for example, when I show you this right triangle, the big right triangle, I've got a big right triangle, I've got a small right triangle here on the left, and I've got a medium-sized triangle here on the right. And notice what happens. The hypotenuse of this little triangle here, this little right triangle, is actually the smaller leg of the big right triangle. And let's say I talked about where X is here. If I label this altitude X, well, this X is the longer leg of the little right triangle, but it happens to be the short leg of the medium-sized right triangle. So you have all these sides now that, have two purposes in the bigger picture. Last one I'll talk about is this side here that I'm showing you is the longer leg of the big right triangle. But notice this side is also the hypotenuse of the medium-sized triangle. So what ends up happening here is when we want to solve for particular values, and in this case, the geometric mean, which is this value here, we take the positive square root of the extremes. Now, here's what that actually means we do. We start to set up a proportion. And so much of our previous chapter was about proportions and similar figures. So this A here is the short leg. I'm going to label it SL of the first triangle, the small little triangle. And X is the longer leg of this triangle, right? So if I was to set up a ratio of that, I would say, okay, well, small leg over long leg. So small leg over long leg. So A over X. And now look at what happens here. If I now look at this triangle, the medium-sized, that X, that was the long leg, is actually the short leg of this triangle here. So if I set up another ratio, X is also the short leg, and B is actually the long leg of this medium-sized triangle, right triangle. And if I set that up, it would be A over X, so short leg over long leg, is equal to short leg over long leg, X over B. And this is now a proportion. And what we want to see is that the X is diagonal from each other. That tells us that we are in good shape for right now. So now if I wanted to solve this proportion and I use cross products, notice what ends up happening. The value of X, the geometric mean, is the positive square root of the product of the extremes. So what actually happens is the value of this length X would be from taking A and B, multiplying them together, getting the product, and then taking the square root of it. So you can set up proportions to solve this value X. You could also just say, I know this value is equal to the square root of the product of A and B, and substitute it in that way directly, and then solve. So there's going to be quite a few cases that we end up seeing with values in different places in the figure. And as long as we just know what we're looking at based on that previous example, then setting up the proportions becomes really routine. So again, if I wanted to look at this figure and say, okay, well, 2 over X, so short leg over long leg, and then set that equal to this same short leg over long leg, my proportion would be 2 over X is equal to X over 50. And then I would use my cross products and then solve. And this one ends up being so super nice. And something else I wanted to show you is that the geometric mean is actually just the average in a geometric sequence. So if I gave you this 2 and I gave you this 50, what I'm really asking you is geometrically what number would be in between 2 and 50 if you were doing a geometric sequence. And it's 10. Because think about it, 2 times 5 is 10, and then 10 times 5 is that 50. So really, when you solve for this value and you find out that this is 10, it makes sense. 2 times 5 is 10, 5 times 10 is 50, and it just perfectly goes through. So then same idea, if I said to you, hey, find the geometric mean here, 8 to 10, so you're thinking 8 times what number gives me some value x, and then if I multiply that x by that same number, I'm going to get 10. Now, I mean, it's going to happen, but it's not going to be obviously a friendly number like 10 in the previous problem. But let's say I set this up the same way. 8 over x is equal to x over 10. We go to use cross products. And now remember, when you go to take the square root of 80, we have to simplify our radicals, so you always want to break it up into the biggest perfect square. Biggest perfect square that divides into 80 is 16, so it's radical 16, radical 5, which then becomes radical 4. So remember, when you're simplifying radicals, you don't want to break it up into 4 and 20. 4 is a perfect square, but it's not the greatest perfect square, and then radical 20 can still be broken up. So you always want to shoot for what's the biggest perfect square that divides evenly into that radicand of 80. And now this one. So this one, I'm actually giving you the geometric mean of x, and we're trying to figure out one of the extremes. So I set it up the same way. 8 over 6 is equal to 6 over x. Also, always notice this trend here that, the x's are diagonal, and now the geometric mean is also diagonal to each other. And so then I get 8x equals 36. And this one ends up just not being a radical at all, not even taking a square root because you are given the geometric mean, and we end up getting 4.5. Okay, so now the next part is just more practice now in understanding and setting up these proportions. So I made a little note here that, you really have proportions using h, the hypotenuse. So I might be using the hypotenuse to set up proportions. Like I mentioned before, a hypotenuse could also be a long leg, or the hypotenuse could be the short leg. You have 3 similar triangles to work with. So you have the big triangle, WXY. You then have the similar triangle to that, which is XZY. Now look at the order. So W, the angle of the big triangle, right, would have to go with, if I'm talking about the medium-sized triangle, this angle X. So those angles are actually the same. To the small triangle, the little small triangle, notice it has W in common. So look at that. The small triangle and the big triangle both have angle W. Then if I was looking at angle X, the smaller angle of my right triangle, that would correspond with, in my medium-sized triangle, oh, sorry, I needed to label this whole thing. Looking at that, that would correspond with my right angle, so that's my right angle here, which also corresponds with the same angle here. And then the last angle, Y. So notice in the big triangle, Y is my smallest angle, which corresponds with the smallest angle of the medium-sized triangle, which in the small triangle is that little angle where X is. Okay, this little angle here. So I know that looks super crazy. I marked so many things up. But again, a reminder for you, this side WX is a hypotenuse of the small triangle, and it's also a short leg of the greater triangle, the biggest one. This length here, XY, is the longer leg of the big triangle, but it's actually also the hypotenuse of the medium-sized triangle. And then this segment here, XZ, is the little leg of the medium-sized triangle. The longer leg of the small triangle, and the short leg of the medium-sized triangle. And so you see you have all of these overlappings happening. And so as long as you have values and you say to yourself, okay, I can set up a hypotenuse over short leg because I'm also given a hypotenuse and short leg of another part of this diagram, and that's going to help me solve my proportion. That's what's going to end up happening. All right, so now I've got two problems here for us that we're going to be taking a look at. And sometimes you can't solve things in the order. So if I gave you X, Y, Z, maybe you have to solve for Z first. Maybe you have to solve for Y. But we use what we're given to set up these proportions, and then we solve. So if I said to you, hey, solve for X. So I would notice that X is a hypotenuse. It's also a short leg of the big triangle. So it's a hypotenuse of the little, and it's a short leg of the big triangle. So if I said, okay, well, I want to solve for X, I know it's a hypotenuse and it's a short leg. Can I set up another proportion with a hypotenuse and short leg? And notice that I know the X is the hypotenuse. I know the short leg is 3. And when X is the short leg of the big triangle, I know the entire hypotenuse is 15. So if I said to you, I'm going to set up a proportion and I'm going to do hypotenuse over short leg, then I would also be able to say, well, X over 3 is equal to 15, the entire hypotenuse of the big triangle over that same short leg, X. So notice I'm using X in common here. So hypotenuse over short leg of the little triangle is equal to the entire hypotenuse of the big triangle over that same short leg. Then I would use my cross products. So we're always getting the positive square root, simplify our radical, and you end up getting 3 radical 5. So now y. So y is actually just like in the first geometric mean problem I solved for. In this case, I could say, short leg over long leg. So when I'm looking at 3 and y, I notice y is the long leg of this small triangle, and it's the short leg of this medium-sized triangle. So 3 over y is equal to y over 12. Use my cross products. This one ends up being really nice. It's just 6, which, remember the geometric mean? If this is 6, so it's the geometric mean in the geometric sequence, 3, 6, 12. So multiply by 2, multiply by 2. Z. Okay, so Z is the hypotenuse of the medium-sized triangle, and Z is the longer leg of the big triangle. So it's a hypotenuse and a longer leg. So if I say, okay, I'm going to set up hypotenuse over longer leg, I would then be able to say, well, 3 radical 5, this is just one of the ways to do it. Since I know X is 3 radical 5, I could set up 3 radical 5, this hypotenuse, over the longer leg of 6. This would be just one way to be able to do this. I could also look at the hypotenuse of 15 and set that over the longer leg of Z. So I could set it up this way, or I could set it up as Z over 12. So again, that's a Z. So hypotenuse over long leg equals, so the hypotenuse of the big triangle is 15 over the long leg of Z. And I promise you, no matter which way you choose to set it up, you're going to get the same result. You will end up getting 6 radical 5, which makes sense because 12 times 15 is 180. Radical 180 simplified is radical 36 radical 5, which becomes 6 radical 5. Okay, so this one here. If I wanted to solve for X, so X is a hypotenuse and it's a short leg. So if I said hypotenuse over short leg, X over 6, the only problem is here, I don't know this entire hypotenuse. It's 6 plus y. So solving for X might not be the easiest thing to do here, although some of you might say, well, hey, it's a right triangle. Can I do Pythagorean theorem? And technically, yes, you can. I'm just trying to show you in this lesson today how to do it without using the Pythagorean theorem. So let's say I just jumped over to y, and I wanted to solve for y first. So, okay, so short leg. So 6 over 8. So if I do short leg over long leg, so 6 over 8 is equal to 8 over y. Okay, short leg over long leg, short leg over long leg, cross multiply. We end up getting 32 thirds. And I'm just going to label that. And so now technically I do know the hypotenuse. It's 6 plus 32 thirds. So if I did want to say x over 6, so hypotenuse over short leg, 6 plus, so hypotenuse over short leg, so 6 plus 32 thirds, I'd have to say, okay, well, this is 18 thirds. So 18 thirds plus 32 thirds is 50 thirds over x. So hypotenuse over short leg is equal to hypotenuse over short leg. Notice the x is diagonal. So this ends up being nice because 6 times 50 thirds, 6 times 50 is 300. 300 divided by 3 is 100. So it ends up being x squared equals 100, which is 10. And I'm just going to label that as 10 because maybe I want to help that in using it for something going forward. And now z. So z is a hypotenuse. It's also the long leg. So if I wanted to set up a proportion and say, okay, well, the long leg, so long leg over short leg even, and then set that equal to 8 over 6, long leg over short leg. And for some reason, I keep ending the last problem for z with some part that doesn't have anything to do with it. There's nothing in common, which I think is kind of funny. Long leg over short leg. So I could have done, long leg, call z a long leg over the hypotenuse and done z over, 50 thirds is equal to the long leg of 32 thirds over the hypotenuse z. Maybe not the friendliest with so many fractions, but as long as you set up a proper proportion, then you are going to be good. And you end up getting 40 thirds for that answer. Okay, so I have 2 last problems here for you as just additional practice. If you wanted to copy this down and try it out on your own, you certainly could. Otherwise, just take a look with me. So here we have 10, x, y, z, and the full length is 20. So I'm given a hypotenuse of 20. I'm given a hypotenuse here of 10. I'm given a short leg of x, a long leg of y, and of course the long leg of z. And so, I could solve for any of these variables. It would not matter. But let's say I did set up this ratio and I said, okay, well, I'm going to work with a hypotenuse over the short leg, because I noticed this 10 is the hypotenuse of the small triangle, and it's also the short leg of the big triangle. So if I do 10 over x, hypotenuse over short leg, I can now look at the big triangle and say, okay, well, the big hypotenuse is 20 over the short leg of 10, and notice the 10s are diagonal. Cross multiply, and we end up getting x equals 5. Now, the nice thing about this problem is, well, if this is 5 and I know the entire length is 20, then of course that means y is 15. And now if I wanted to solve for z, so z is a hypotenuse and it's also a long leg. So if I wanted to set up long leg over hypotenuse or hypotenuse over long leg, I could say, okay, well, z, if z is the long leg, the whole hypotenuse is 20. Whoops. Okay, so z over 20, so long leg over hypotenuse, would be equal to the long leg of 15 over the hypotenuse of z. So another long leg and hypotenuse. Cross multiply, we get the square root of 300, which ends up being 10 radical 3. Okay, last one here. If you want to give this one a shot on your own, please do. Press pause or just keep watching. So I might want to find y first here. So 4 over y, so short leg over long leg is equal to y over 6. Cross multiply, and you end up getting the square root of 24, which is 2 radical 6. And so I'm just going to label that as 2 radical 6. So now if I wanted to, let's say, solve for z, if that's what I want to do, it doesn't really matter. Z is a hypotenuse and it's a long leg. So if I set up 6 over z, and 6 is the long leg, and the hypotenuse is z, I need another long leg and hypotenuse. Well, so 6 over z would be equal to z over 10. So the long leg here over the entire hypotenuse. Okay, cross multiply, and we get 2 radical 15. And then the last problem, to get x, notice x is a hypotenuse and it's also a short leg. So if I use x with a hypotenuse and as a short leg, and I set up, let's say, x over 4, so hypotenuse over short leg. So a hypotenuse of x over a short leg of 4 is equal to the entire hypotenuse of the big triangle 10 over that short leg x. Cross multiply, and we end up getting 2 radical 10. I hope this video was helpful for you. Thank you so much for watching.